So you want to incorporate machine learning into your next embedded design. Sounds great. But where do you start? Well, if you're a machine learning expert, sky's the limit. But what if you're a machine learning novice? Or maybe you know just a little bit, but not enough to get the job done. Well, let me introduce you to NXP's Freedom ecosystem. It's going to break down that machine learning complexity with ease and get your design on its way in no time. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Michael Pontikes from NXP and I explore the details of the Freedom ecosystem from NXP. We investigate the scalability component of this ecosystem, the details of the Freedom i.MX 93 development board, and how the machine learning software and tools of this ecosystem will streamline and simplify your next machine learning enhanced design. And before we get started, don't forget to click that link. There you can find even more information about this topic from NXP. Hi, Michael. Thank you so much for joining me.
Yeah, thanks. It's great to be here. Looking forward to talking about the NXP's Freedom boards, and yeah, just excited to be here.
Excellent. Okay, so we're talking about how we can break down machine learning complexity using NXP's Freedom ecosystem. But we're talking about a variety of different applications here, right?
Yeah, so really machine learning can be a lot of different things. I mean, I feel like we hear it all the time now in the news, machine learning this, machine learning that, but kind of the scope that we're looking at in this particular case is three different things. It's this vision, voice and sound, and time series. And start off with vision, we can really think a vision more like the things you would see like in a car. So if I'm driving down the street, right, I want to make sure that, there's not a person in front of me, or if there's, maybe there's someone behind me. We can use machine learning vision to really determine like, hey, there's a person on the sidewalk, watch out for them. Hey, there's a car beside you, watch out for that. And it allows us to get information from around in the environment. Another thing that we can do is a gesture control as well. Say you're in the car and you want to say, increase the volume or increase the AC. You can do a hand gesture and it would increase that. I typically like to say less than the car, but more like in an elevator. Say you want to go to floor 3. It's as easy as holding the number 3 on your hands up to the camera and it'll take you to floor 3. So vision has some really cool use cases there. Another great use case is voice and sound. I'm sure you may have used the Amazon Alexa, Google Home, and any of these other smart voice assistants. They use machine learning to determine what you're saying and then transcribe that into text. Another thing that we see as well as this alarm analytics where, say, if someone threw a rock through your window, you'd probably want to know about that, right? Like that's something that's important to know about. So we typically say that in determining if a noise was, say, a window break or something that a user might want to be notified about. And then finally, we have our industrial use cases looking at things on a, say, conveyor belt or a assembly line and saying, hey, something might not be right here. We're seeing a weird power draw from some sort of machine and informing operators on that to act on that. So yeah, machine learning actually has a lot of different use cases beyond, running numbers. It has a lot of great use cases we see in the real environment today.
So, Michael, before we dig into the details of the solutions in this space, let's talk about machine learning a bit.
Yeah, so this, just to preface, is a very, 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 very high level idea of what machine learning is. I'm sure some people are going to watch this and say, hey, this is too generic, but try to get the idea out there. So in traditional programming, when you say write a C file or, write an application on a computer, typically you say like if, else, do this, write these, you say if this condition, then do a thing. And so in machine learning, it's kind of the opposite where we say, okay, so we have a model, which hypothetically can identify a certain, say, like, for example, object detection, figure out what an object is. We go to the model, it has a lot of parameters. We say, hey, here are the answers and here's the data that's for the input. So for example, that for object detection would be, hey, here's a bunch of pictures of cars and these all should be ID'd as cars. And we let the computer determine what those parameters should be set to. So we run through a lot of different training cycles to figure out what these rules should be, what the parameters should be set to. And that is how we kind of get this machine learning idea, is that instead of the user defining the rules that we have for a program, we're now letting the computer do it. by kind of guessing and checking over millions of times to figure out what the correct answer is.
So, Michael, there's a training phase and an inference phase, right?
Exactly. So there are two different types of phases. As I was talking about earlier, there's this idea of going through and taking this data and trying to determine what the correct values for these parameters for this model should be. That's done in the training phase, and that's typically done on very large servers, typically things that you do on a cloud computer, on powerful GPUs, and you're just going through data sets, trying to determine what this number should be. You're then taking that model and testing it in the wild, typically on two different data sets, and determining, hey, does my model actually work, or is it still need work? And so once we figure out, oh, it needs work, it goes back to training, maybe tweak the data set a little bit to make sure that we get those things that we weren't getting in the first model, and keep doing it over and over and over again until we have a model that works very well on the test set. Once we have that model, we can then move the model onto the inference phase. This inference phase is basically taking an unknown input. Say this is like your device that you're deploying on the wild, your edge device, say like a camera frame or something, and you take that camera image, throw it through the model, and you get a prediction. And so that, you don't need to have a GPU since you're only doing one of the, as you call it, of these inferences and not millions of them. And that's typically what we see in the inference phase as the model has now been finalized.
So, Michael, talk to me a bit about the machine learning systems implementation.
Yeah, so with the whole machine learning kind of systems, there's a lot of different options that you can do. And a lot of today's kind of the flashy new stuff, a lot of that's being done on the cloud. So for example, the large language models and things that require a ton of GPU processing just to do a single inference is typically done on the cloud. And that's what you're seeing a lot of the news right now. But that's not the only thing that machine learning can do. Like I was saying with the object detection and object classification, those things actually be done locally on small embedded devices, which allow us to run these things not on the server, but on a device that may be local to your network or even local to the device itself. So that's why we see these rich nodes on the edge. These are a little more advanced models, maybe take a little bit more compute power, maybe a bit more expensive hardware, but can still be done locally. So say if your external internet connection got cut off, say that something happened where your ISP is like, hey, like we had to shut off your network connection for a bit, you wouldn't be stuck stranded without any of that compute power. We even actually can go even lower to the device itself. So for the kind of the rich node idea, that would be something like a smart hub that you have in your home that your devices report back to, and you would run the inference on the smart hub. But we also can do, say, for example, in this picture, we have a smart door lock. You can actually do it on the device itself. So I can walk up to the device. It doesn't need to be connected to anything else. Just walk up, look into the camera. It's able to determine that I am me, and it's able to let me into the building. So there's some really cool stuff you can do with these embedded devices, and it's kind of what we're going to be talking about a bit later in the presentation about these Freedom boards. There's some really cool stuff that you can do locally, and you don't really need to have this, cloud compute, these major, servers with all these GPUs on them to really run these ML workloads.
So, Michael, what kind of benefits do these Freedom boards bring to the table for these kinds of designs?
So the idea behind the Freedom ecosystem is that we are able to bring these technologies to the general consumer. So anyone can buy one of these Freedom boards off the shelf. They can take them, develop on them, and utilize this technology that a lot of times isn't available for the general public. I'll also be talking about a little what those technologies are with the Freedom board for the 93. But they're low cost. They're also able to connect different devices to them as well to try to customize them to be what you're kind of looking for. So, for example, if you want to add a camera onto it, there's modules for cameras, there's modules for screens, there's modules for all sorts of things. And that's a really cool thing NXP is doing to essentially bring the technology that people would typically need to pay upwards of $600 for an EVK board down to something much, much cheaper. It's great that we can kind of see this kind of accessibility for this technology for a lot of people who can't afford it, a $600 EVK. And also, the Freedom board isn't just hardware. We also have a lot of software as well. And I'll be going into a lot more detail on this later in the slides, but there's a lot of great example code that can really get you started and running really quickly.
Fantastic. Now, Michael, a big benefit of this solution is scalability, right?
Yeah, so the idea behind these kind of MCUs and MPUs is that you can really scale the power that you need to the use case that you need. For example, like we're going to be talking about the Freedom 93 board a lot during this presentation, but that's not the only thing that's available in the Freedom ecosystem. We have a lot of MCN devices that are great for you to use and for you to use for maybe something that doesn't require the power of the i.MX 93. We have our Freedom MCX boards, which have a lot of ML use cases as well. So say, hey, I don't need to have the HDMI and all this, the Wi-Fi and all this, a Linux system. Well, you can go down to the Freedom MCX boards to still experience the power of having an onboard NPU, but you don't need all of the fancy features of the 93. So the Freedom ecosystem really does allow you to go and pick the Freedom board that best fits what your use case might be.
Michael, can we take a closer look at the Freedom Development Board you mentioned earlier?
Yeah, so the Freedom board for the i.MX 93 is a new board that we have released. It essentially takes the power of the i.MX 93 applications processor chip and puts it on a nice small Freedom board kind of form factor. This is the first actual board that has come out with an i.MX NPU, which is really excited. That's kind of the area I work in, so I'm especially excited about this. It includes a lot of really cool modules as well, including a Wi-Fi module, Bluetooth module, and that just allows you to connect any of the devices that you might be wanting to work with. And this being a IoT device, you can also connect to the network as well, so it's really great for application development. It's about the size of a credit card, maybe a little bit bigger, but it's really cool because I can just, all this cool technology is just on this super small device, and I can just take this wherever I want to go, wherever the development might take me. Like if you're a student, you could take this with you to campus or wherever, and it's a really cool little device. We also have, again, like I was mentioning earlier, great technology in the software as well, where we have support for Debian, Yocto, and GoPoint, and I will be talking a lot about that in the next couple of slides, so I don't want to spoil too much about that. But yeah, I'll be talking a lot about the software implementation as well, because the hardware is great, but the software to actually get it running is also very important as well.
Cool. Okay, so walk me through some of the details of this board.
Yeah, so to look at more of the deep dive on kind of the technical aspects of this board for the hardware side, we do have 2 Ethernet ports that you could use to, if you're not wanting to use a Wi-Fi module, you can use Ethernet ports there. The Wi-Fi module is an option if you want to use that along with the Bluetooth as well. It's a tri-radio, to call it band, so you can also use the 802.15.4 band as well. And there's also some other cool technologies for like security. So for example, the edge lock security enclave, that's going to be used for some of the kind of security use cases as well. There are a lot of very cool things technology-wise. One of the things that we can look at as probably the most important thing is the actual processor itself. So the i.MX 93 processor chip does contain 2 ARM Cortex A55 cores with a Cortex M33 chip as well. You can use the main Cortex A cores to run kind of the heavier workloads that you have, kind of the things that you typically run in a Linux operating system. And then the Cortex M can be used for more of your MCU use cases as well. Those are kind of a cool little, 2 processors in one type thing here. Already mentioned the Wi-Fi, the Ethernet. So we also actually have a connector for an expansion boards and adapters as well. It's a 2x20 header that allows you to connect all sorts of things onto this board. So it's really a great feature for that. You can load things onto the onboard storage, so the eMMC, which is 32 gigabytes, or if you need more space than that, you'd also load things onto a micro USB, which there's a slot under the board for that. But yeah, there's a lot of other technologies as well for you to explore with. There's a onboard HDMI connector. There's a onboard audio jack. There's plenty of USB-C ports to go around. So there's a lot of really cool things on this board. And honestly, the best way to experience it is to try it. But yeah, there's a lot of cool hardware features on this board. And I'll talk a little bit more in the coming slides, but especially about the NPU, which I think is kind of the highlight of this board. So on the point of this NPU, it is a NPU accelerator, which essentially NPU stands for Neural Processing Unit, and allows you to load machine learning models onto this specialized hardware and run them extremely quickly. It's very power efficient as well. It allows you to take the load that would be on the CPU off the CPU and onto this NPU and run them on there. So while a machine learning model might take up all your CPU cores, if you're running on the CPU, the NPU can run it both quicker and more efficiently than the CPU can. So there's a lot of really cool features with the NPU, and I'll talk about how to enable it, but the NPU really does allow you to, where traditionally on these smaller A-core processors, you could technically run a machine learning model, but it really wouldn't be very fast. It would be almost like, okay, cool, we get something like 1 inference per second, but that's not very helpful. But these NPUs, you can go a lot faster than that. And depending on the model, depending on the input size, depending on a lot of factors, you sometimes can even get real-time processing out of the NPU. So a really great feature. And the thing, honestly, for me, I'm most excited about with this Freedom board is this NPU, because it's really cool to see what people are going to do with this micro NPU that will be included on the 93 Freedom board.
Fantastic. So, Michael, walk me through this toolkit as well.
Yeah, so the toolkit here we have essentially is to help you all to move your stuff onto this new kind of NPU. So we have 2 different kind of workflows that we typically see with this toolkit. So for the first workflow we have is this bring your own data set. So let's just say you have no idea what machine learning is. You come in completely blind and you're like, okay, this is really cool. I want to learn about it, but I have no idea what I'm doing. This is typically the best way to go for very, very new beginners. Essentially, you're able to take photos and import them into this tool. You're able to categorize them inside the tool as well. And you're able to then train on that data set. So as I was saying earlier, we kind of have these 2 phases of this training phase and this inference phase. The bring your own data set is a really great way to kind of streamline this training phase here. So the EIQ Toolkit portal, it does have 2 supported features right now for classification and detection, and is able to train models that you're then able to use on the i.MX 93. The other option that you can use, if you are experienced with machine learning, or you just maybe downloaded something from the internet and wanted to try that, you can try our bring your own model workflow. And essentially what that is that we have a lot of different frameworks for machine learning, and you could take your framework that you're using and convert it over to something that the i.MX 93 can understand. So I won't go too much into technical details, but essentially if you said something like PyTorch, you can convert it from PyTorch to Onyx to TF Lite, and that can go on the 93. It also has a great visualizer, so you're able to see like, hey, what's in this model, what's the input size, what's the output size, and personally for me, it's a really great tool to just kind of look at a model and see, oh, something's gone wrong, and half the time it's wrong input size or something. So it's a great little tool to just visualize a model as well, but also be able to convert the model that we have for wherever you're taking your model from and port it onto the i.MX 93.
Now, besides everything we've already mentioned, Michael, what other benefits does NXP bring to the table for machine learning applications?
Yeah, so machine learning and getting your model ready and getting everything for production is only a part of this kind of whole process, right? You need something to run it on. You need an actual application. The idea here is that we also provide all that as well. And this is the same type of tools that we use for our EDKs as well. So it's really cool that we get to kind of get people's kind of hands dirty with this stuff. So the first thing I like to talk about is we have this open source board solutions package, or a BSP. So the idea behind this open source board solution package, or BSP, it allows our users to really focus on getting their application developed and done, rather than trying to figure out all the low-level coding and Linux drivers as well. We provide a Linux Yocto layer that allows you to build your own custom image. So if you are using Yocto already and have a bunch of things in that system, you're able to integrate your stuff right into our workflow as well. But if you're not familiar with Yocto and are unfamiliar with it, then we also have a Debian release as well to allow people to get familiar with something that they know and love. Because everyone knows Debian, it's a very familiar operating system. So it allows people who are maybe less familiar with embedded development to go into something familiar rather than kind of jumping off the deep end with Linux Yocto as well. But in both cases, these drivers are all included in the package, so you don't have to try to compile an operating system and then try to throw in the drivers. It's all included, so it's really easy to get started with that way. So the IQ Toolkit is not just the portal tool. We also have all other things as well in the tool as well, including support for machine learning operations on the 93. For example, if I wanted to, say, take my model and run it on the i.MX 93 Freedom board, I'm able to do that just out of the box. So I'm able to open up the board, throw my model onto the board, and then run it, and it will work, which is great. It's a cool thing. Provided that you convert it using the IQ Toolkit, but I don't have to go into TensorFlow Lite and try to enable a bunch of custom features and try to change the settings of TensorFlow Lite to get it to work with NPU. It's already done for you, which is great. So we have both the underlying operating systems available for you. We have a lot of machine learning tools, which are really great. I did also want to mention the ARM Vela compiler. That is, it's on the slide, so I want to talk about it. It is a compiler. Whenever I say convert the model to the i.MX 93 Freedom board, it's just using that compiler to convert. And then finally, giving you all the example applications that I was mentioning earlier, we have what we call GoPoint, which is essentially a suite of applications that is included in this BSP or board support package. So when you turn on the board, there's a bunch of demos that are available for you to run and see kind of the power of the i.MX 93 firsthand. Something that is cool too is that all these examples are open source. So if I say, hey, I want to run a object detection demo, well, I can just go to GitHub and see the application code for that specific demo, which is really cool and allows you to not kind of walk around in the dark. You can see an actual use case running on the actual hardware and not just hypotheticals, which is great. So there's a lot of cool demos in GoPoint for machine learning, for graphics, and a lot of other things as well. We also have the application code hub. So we can't include all the demos we would like to in the BSP for various reasons. So we also have the application code hub for even more demos and even more use cases that you can look at. So, and that's being updated as well. So it's only going to get bigger and there's only going to be more things on there. So I'm very excited to see where App Code Hub goes, and GoPoint will of course be updated. So some very cool things happening on the Freedom board, and also some very cool applications that, again, are all open source. So you can use them in your projects, and it's a great way to get started very quickly.
Okay, so if my audience is ready to get started, where should they go first?
I would say if you have a 93 Freedom board, the first thing is the out-of-box experience for GoPoint. I talked about it a bit earlier. GoPoint is this out-of-box application that has a lot of really great demos and a lot of really great applications. And so I would really recommend going there first, because that's easy. It's you just kind of plug in the board, plug in the HDMI cord and Ethernet cord for some of the demos because they require downloads, and run the demos. And it's a really cool application. And again, more stuff we would like to add to GoPoint. So, as we develop it more, there'll be more demos. So it's a cool thing. It's also a simple GUI, so it's easy for most people to use. You don't have to go into the command line or anything. So really great application, and something that we're very happy about here. The other thing that we have, you can actually go to NXP's GitHub page now, and you can actually see a lot of the examples that are included in GoPoint. So if you just want to check out the code, you can do that right now, going to GitHub and searching up NXP Demo Experience is the repo's name. The reason why there is a name difference is just because we recently renamed that to be GoPoint. NXP Demo Experience, if you search that in GitHub, you'll see lots of different examples that you can use on the 93 Freedom. So a lot of cool stuff there.
All right. So, Michael, where should my audience go for more information?
So yeah, we talked a lot in this presentation all about software tools, the i.MX 93 Freedom board, and a lot of different stuff. So I'll leave you with 4 different things here. So for the software and tools, we talked a lot about the IQ toolkit with the portal tool allows you to, if you have a model, convert it to be usable on the i.MX 93. But also, if you don't know about machine learning, you can use that tool to train your own model and port it onto the 93. So there's a lot of great information at nxp.com/eiq. So I would recommend, if you're interested in the embedded machine learning, to check that out. Of course, I'm going to talk about a bit about GoPoint. GoPoint's a great resource for you to check out. And I talked a lot about it last slide, so I won't go too much into it in this one. But there's also Application Code Hub that also has a lot of demos and example code. Even if it isn't for the i.MX 93, there's also a lot of code there for other devices as well. So even if you're like, oh, well, I'd rather have the MCX board, Freedom board, rather than 93, that's also a great place to go just to check out the code on there. We'd also have a technical training as well, so we definitely recommend checking that out as well to get more familiar with the Freedom board. And then finally, we have the landing page for the Freedom board, which is nxp.com/FRDM-IMX93. That's where you can find all information about where you can get the board, where it's being sold, and just more information about it. If you're especially intrigued in a certain aspect of the board, there's lots of information on there for you. So I would definitely recommend checking that out if you're at all interested in the board. And yeah, it's a cool little board that puts a lot of power in not a lot of space. So definitely a very cool thing to have in your back pocket.
Excellent. Well, Michael, I think that's all I have time for today. Thank you so much for joining me.
Yeah, thanks for having me. It was really great talking about the Freedom boards and the i.MX 93.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from NXP. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EE Journal.